Okay, here's my interface for our Arduino emulator. It uses a serial port, which is what I wanted to do because it's easier to get a computer to have a serial port than a parallel port, since most likely the adapters that convert it, which is USB, only do the pointers, not anything else. And that can cause a problem. Anyway, what we got here, this is basically has two inputs, two outputs. It can go up to like, I think 4 inputs and 2 outputs. If you use a different type of cord wiring, but I'm going to use a Cisco console cord so that it can use a popular cord that you can get, and it could hook up to the RJ45 box so that you easily wire it up. One of those boxes that they use or a wall plate that has a network connector on it. Use it mounted on the wall and network cord. Anyway, we got DTR, data tuner ready, request to send. These are transmit and receive when there's ground. Then we got clear to send and data set ready. Is one of our data set ready and clear to send are our inputs. Then data tuner ready and request to send are our outputs. IO plus on the right there that connects to the collectors of each output buffer of each transistor are there, so you can have specify which voltage you want for your output on the high part. The diodes it uses can be rectifiers or switching diodes. For really switching, because if you want to do high speed stuff, you can do it that way. It don't probably really matter because it's not going to get that. If I won't get that fast. After all, it's just a serial port on the computer. The transistors usually don't matter. They can be any kind of small power. You can put power ones on it if you wanted to make it stronger than what the Arduino would actually be. Which you could do, but it'll be more expensive. So we just use the minimum power one. This one here, I think, can handle up to about, according to what the data sheet is set, up to 0.5 amp of power. The 2N44400. Anyway, over here, we got the project right here. It looks kind of a mess because there's no circuit board there. I couldn't find one. I know I had one in my room, but I couldn't find it at the time. So I just decided, why don't we just solder it like that, and then take the wires and put them between the screws. And it did pretty good. Nothing shorted out because I tested it out with it. Nothing, because this power supply couldn't be going for one over here if this was shorted out or higher than this. Right now it's on nothing on there, which is exactly what it should do when it's hooked up to power with nothing happening. Because there's no current being flowing. Right now we gotta input 5 volts. That's basically what our Arduino would output to those pins. So we put that through there. So this is basically our Arduino output. Now we got our battery here. That this battery here will be acting like the serial port. and serial port, and sometimes Arduino in this video. The thing is, those resistors they can handle, like, made to handle more than 5 volts, like 9 volts or so, or 12, up to whatever, how much it's supposed to be. Anyway, if I put the camera down, grab a hold of this red wire here, I'm gonna put it to positive. Sometimes you can touch it. Look, even if I touch the wire, it does a little bit of switching on it, but not that much. As you can see, the meter went to 0.42 volts, which is way below that. It's because it's picking up static. So what we're going to do is take the red wire here. I think, yeah, red wire here goes positive. And then there should be a smaller red wire on the white side that's going to go negative. Cutting these different colors, but couldn't find any. Careful not to short the battery out. It's not good to short the battery out. Ooh, it went up. There we go. As you see, I have it turned on. You see when 4 volts cost it, which it dropped a little bit. From 5.08 to 4.4 it said. That's because of the transistor has a forward voltage drop, just like a diode does. And if I put it backwards, you should get nothing out of it. Of course, it's getting something because I'm touching it. Hang on, I got to get the wire on there. And look at that, we got nothing across it. This is because it's off. At that time, a negative on that line. There's just a negative to the output, like on it. It's just that we got the negative on the other lead. 2 negatives won't have no current flow, because it has to be both of them has to be a positive and a negative in order to flow. Not 2 negatives or 2 positives. Now next thing I'm going to do is I'm going to show you the input buffer. We just did the output one. So now I'm going to wire up one of the input buffers. That means I got to take the black lead of my meter, and the black or red, doesn't really matter, because you can tell if it's working or not, because if it gives us a reading on it. And also, look at now, I got it. Sorry about that. Lost the click button and it stopped recording. I also got, now I got, listen, it's unhooked, the battery's unhooked to it. And I got the negative hooked to the positive. As you can see on on our meter, we're getting negative 4.98 volts, meaning it's wired oppositely. And that tells us that we're getting negative out to it, so it gives us a negative, which is exactly what we want. The next thing I'm gonna do is gonna wire it up to one of these. Okay, now I'm gonna wire up to the pin on it. Right now it's not that power not turned on, and it's at 0.91 volts on it. Could be leaking through the rest of the circuit on there. Could be. Yeah, if it's negative, it could be. But when looking at the input, yeah, input. Yeah, it could be. I don't know. Anyway. So what we're going to do now is going to take the 9-volt battery, we're going to go to the base of Joe resistor, of course. Yeah, make sure you put resistors on it. Otherwise, if it goes to the base, collector on there doesn't have resistors that goes to the serial port because they're the low current on there. The current is just very low, and it shouldn't go over 500 milliamps. So it sure should be safe. This wire to go in. As you can see, I switched it on. If I can hold it in there, you get the 4.98 volts across it, which tells us that works as well. And I just did it backwards, and also it doesn't turn like that either. So both ways work. Now to test it what it's supposed to do with the real circuit. After it gets fully finished, what it's supposed to do with the computer, we'll have to get that cord first. Well, that's it. So I hope you enjoyed this video. Thanks for watching if you like it.